Now, as regular listeners will know by now, this podcast is about how technology is transforming multiple industries and solving real-world problems, rather than talk about bendy or foldable screens. Now, although Mark Cuban declared that data is the new gold, too often I'm quite conscious that huge amounts of data can't answer the questions that actually matter, because they deliver billions of isolated facts, but zero intelligence. Now, a company called Data Chemist recently appeared on my radar because they're attempting to solve this very real problem. They impose and enforce real-world rules onto data, and by doing so, giving their customers more insight than they've ever had before. Data Chemist is actually making complicated simple, and they're transforming messy, inconsistent data sets and transforming them into clean, structured, integrated data, and transforming isolated data points into a model of the world as it really is. And the result? Their customers improve decision making and reduce costs as a result. Now, ladies and gentlemen, that is a story that excites me. So buckle up and hold on tight as I beam your ears all the way to Dublin in Ireland so we can speak with Kevin Feeney, CEO of Data Chemist. So a massive warm welcome to the show. Can you tell the listeners a little about who you are and what you do?
My name is Kevin Feeney. I'm a CEO of Data Chemist. We're a company, a startup company that spun out of Trinity College at the start of 2018. We build enterprise knowledge graphs. And what that means is we take all an organization's data, which is typically very messy. We integrate it all together into a single connection-oriented model, where all of the data is modeled as entities with relationships between entities, for example, customers and accounts and customers and orders. And we can see all this data integrated together in a great big network. And then this makes it amenable to a huge suite of mathematical graph analytics, where we can find lots and lots of patterns that are hidden in the data that were previously invisible.
Now, when I was researching you guys, I quickly learned that Data Chemist builds these enterprise knowledge graphs with powerful logic constraint engines. But can you just tell me a little bit more about exactly what makes it unique and what kind of problems you're solving with Data Chemist?
Yes, there's an area of graph databases which is where we belong, and this is a different way of modeling data from the traditional SQL relational databases, where we have basic tables, columns, and rows. This connection-oriented view is becoming it has several very strong use cases in fraud detection, supply chain analysis, in networked risk, in a lot of these areas where it's very important that we don't just look at a single entity, we look at how it's related to lots of other entities. So, for example, in supply chains, we can easily have a node failing, for example, a supplier of a company failing, but at multiple hops distance that has a knock-on effect on the particular company. So any use case like that where we have data that the relationships are very important and we may have to look at multiple hops of relationships, the traditional database technology is just not very good at this. It doesn't do SQL technically doesn't do very good at joins at scale. If we have hundreds of millions of these records, for example, we can't see this. And there's lots of areas, for example, in financial services where companies, where regulators, for example, stock exchanges have these vast streams of data. There are bad actors in that data who are trying to disguise what they're doing, hide behind third parties, hide behind agents. And we can make this very clear, or we can see this very clearly in the data, but we have to be able to understand all the connections of all the actors. So increasingly, this is at the forefront of data technology, being able to create these very large graphs of relationships between entities and analyze these at scale. Now, what makes us different? There's basically two families in this in that world of graph database. There is what's called property graphs, and then there's RDF semantic web graphs. The second one, semantic web, is very academic. We can make very rich descriptions of what the data is and do logical inference over it. The second type is much more is the property graphs, which are actually much more penetration in industry. Neo4j is the market leader there. They have a more practical focus, and the big difference there is is that the relationships can have properties as well as the nodes having properties. It's quite technical, but what makes us different, first of all, is that we combine those two approaches. We have a semantic layer built on top of a property graph, which allows us, and what the capability that gives us is, whereas the property graph people are looking at nodes and edges, we are looking at for meaningful business objects. So we have relationships between people and companies, and we can give our graph all sorts of real world meaning, so that it's much more easier to understand by business users.